So that's a great deal of the content that was exciting enough to overcome the dreaded after lunch session position. And so what I'd like to do is ask all of our speakers who are here to come back up to the podium, and those of you who are not here to come to your microphones. And we're going to take some questions. This is your opportunity to ask some questions of our speakers, and we have one right here. Identify yourself, please, and your institution.
Okay, my name is Bob Moses, Tamer Space. I retired from NASA in March 2022 after 33 years as an exploration systems engineer. I enjoyed this set of presentations. One question is, are any of these lunar orbiters going to provide any GPS-like data from lunar orbits? And if not, would you be interested in hearing about a NASA patent that would provide that capability?
So LEXO is not going to be a node by which you can directly pick up a signal. But one of the great things about our one of our payloads is we actually do auto navigation on board, so we know where we are in a very small area by using terrain relative navigation. And with retro reflectors, we can pinpoint a lander on the surface and give a extremely accurate location to that landed asset.
Okay, Clive Neal, University of Notre Dame. I think the last question Ben Bussey should try and answer. With Intuitive Machines putting up a communications navigation network, but that's not my question. My question is for Noah and Charles about LEXO. It's the value for money that we saw with LRO being transferred to LEXO. It seems that message you've portrayed it really well, but it seems to be getting lost in sort of the mix of what else is going on the moon. And I want you to sort of address that value for money that we've seen with LRO, and following that template, if you like, is something that seems to be a no-brainer. But on that no-brainer, I was surprised not to see more high-resolution mapping of the PSRs, especially I didn't see a neutron spectrometer. And I would like to find out what plans there are to do that high resolution of these areas that are supposedly containing volatiles and would potentially allow a sustained human presence at the lunar south pole. So a couple of questions there for you, and maybe one for Ben.
What was your name again? All right, so actually there's the cost return for investment from LRO, and I think Charles can talk to that because
you really need 8 hours of sleep, Noah.
I'm sorry, say again?
You really need 8 hours of sleep.
Let me tell you,
So
it's been a long time.
yeah. So
let's get to the second one, and then I'm going to let Charles answer the cost return, what we learned engineering wise, how to build and do things at the moon more cost effectively. How do we get, again, LRO is unusual because had it ended after 5 years, okay, that would still have been incredible, but now it's been 14 years and going strong. So, but the high resolution, so specifically with neutron spectroscopy, we looked very carefully at what we could get from a neutron spectrometer on LEXO. And one of the requirements of that instrument, and Charles can pull me aside if I go too far astray, was very, very low passes over the target of interest, over the South Pole. So we could have done that, but that would have pushed the design of the spacecraft very, very far in one direction to do one thing very specifically for a short period of time. There's a fuel hit to that, right? And so one of the resources that on LRO, I feel like I'm like on a big board in election night, I'm like gesticulating wildly. That pushed us so far in one direction. We thought, boy, that hurts all of these other instrument measurements that we want to do. So it's very, I wanted to accommodate every instrument. It's like Oprah, I want your instrument, and your instrument, and your instrument, but we can't do all those things and come up with a story, a mission that works for the other three instruments that we have on board. And that's what I said earlier is like, hey, one instrument, one mission alone isn't going to do it. So you know what? If you want to get that high resolution neutron spectrometer, there are 3 other instruments that would benefit from those month-long low lunar orbit passes over the South Pole. Let's do that mission, but that mission is not LEXO.
So we need a dedicated mission for those data.
I would argue that. Charles nodding his head. Yes. Affirmation, baby. So I would say that is pushing us, that would push us to that second type of mission. Me, Noah, that's what I'm saying. Now, Charles can speak to what we've learned about building, designing a mission, and how to get that cost return.
So when we started on LEXO, Noah came to me and he says, we need something more flexible, right? I mean, that 14-month mission where you had about a year, it ended up being 2 years in the 50-kilometer orbit. We need to be more flexible so that we can move from a frozen orbit to a global orbit at will, right? Because there's going to be a moment later on where we want high resolution and it's not at the South Pole that the frozen orbit is. So we've added considerable delta V capability to LEXO compared to LRO. We have consumables for 6 years in case anyone was asking. And in addition to that extra capability, and then you want to think about, so what are we bringing I mean, if we just did that and we flew all of LRO's instruments, you'd be disappointed, but yet it would still be valuable. But wait, you know what? We have much more capable instruments, and we're doing at least a half an order of magnitude to an order of magnitude, in addition to new measurements based on our level ones. And so draft level ones, super draft level ones. I think that we have doubled the science capability of LRO for about the same cost.
Okay, thank you.
Thank you. We are running out of time, so we'll take one online question and then yours. We'll take one online question. Do we have any questions online? Okay, thank you. So we will go with.
Sure. Hi, I'm Saurabh, PhD student at University of Maryland. My question is for Kerry, for the LunarWise. So as I understand, there are 2 multispectral images on LunarWise and the gamma ray spectrometer for the geochemical quantification. So is the rationale for using the multispectral camera and to get the SiO2 abundance and FEO, which you're getting from the multispectral camera, but you're also getting the same like geochemical quantification from the gamma ray spectrometer. So what's the rationale for using the multispectral camera in this case as a competitive thing, or?
Yeah, so when we're looking at the GRNS data, backing out the major elements like silicon and magnesium and iron, is there going to be a little bit more complicated to get than the thorium abundance. We're going to have to integrate for long periods of time, and then we really have to be able to calibrate out the background signal. And so the silica and magnesium and iron content that we're going to get from that data set will be, will be beneficial to us, but really the most accurate estimation that we'll get probably of the silica content really will come from measuring the CF position with a thermal instrument, which is directly related to the SiO2 content. And so in a lot of ways, it's fantastic that we'll have 2 independent means for estimating the silica content so we can really nail the composition of that rock.
Got it. Thank you.
All right. Thank you all very much. That wraps up the mission update session. Thank you.